Hi, good morning. This is Travis, and this is February 1st, 2019. I'm going to re-record this quickly after yesterday's meeting. This is the data from our South Bay Indoor Air Quality Ventilation Optimization Project. So the first slide shows the thresholds that we had established kind of during the design phase of the project. Down at the bottom of this page, you see some of the thresholds that we had set for our detailed sampling that we came in and did in April and June. I should have had those dates sitting here. But we have pretty detailed reports from Healthy Buildings International on April and July of last year with all the chemicals and the organic compounds and the CFUs and things like that that are available to all the project team members. And then the top side of this page is the components that we have on the continuous sensors. So our particle measurement, carbon dioxide measurement, temperature and humidity, obviously, and then the TVOCs and the ozone. This presentation is going to show the particles and the carbon dioxide. I will point out that the particles, or the thresholds that we have from the outdoor air stuff are in PM 2.5. What we're actually measuring in the project is PM 1+. So those are different. So to get into the data, this is the outdoor air CO2. The dates on this are wrong. The period actually goes from 12/14 out to about January 4th. They're right on the next slides. But and the margin of error on CO2 sensors is not 0, it's more like 50 ppm. So you're always kind of looking at a range. And for the period that we're looking at, 450 parts per million is sort of our mean, as it were. Then this is our indoor air CO2 observations for the non-patient spaces. And the way this chart reads, the light gray little box there is 25% of the data, and then those two dark gray boxes are sort of the middle 50% of the data, and then the light gray is another 25%. So each one of these is sort of a bell curve. Within each room, that's the way the data stacks up. The mean of all of this data together is about 500 parts per million in non-patient areas. Then this is the data for patient areas, and again, the mean of all this data comes out at about 500 parts per million, which is to say we're just slightly over, that's 50 ppm over where we are with our outside air in terms of CO2. Very well ventilated spaces. So this is the chart, excuse me. This is the chart showing the theoretical relationship of outdoor air parts per million of CO2 and ventilation rate, and how we would expect CO2 to drop according to ventilation rate. Of course, there's a bunch of variables in that equation, and we don't know all of them, but we do know that the shape of the equation is this logarithmic shape or diminishing marginal return shape. And we're pretty confident based on the data that we've gathered. Obviously, we're within 50 ppm of the outside air, which is to say that we have very, very well ventilated spaces. And we're probably well out onto the asymptotic portion of this curve, which supports our hypothesis that we should be able to reduce these ventilation rates, by half or down to 2 air changes per hour, which is really the code minimum in California, and still have very good air quality throughout while doing so. This is the particle data, and this is the outdoor particle data. A little bit more spread in the outdoor particle data. And without getting into a super long discussion around units, the units that we're looking at here are PM 1+. So it's all particles that are 1 micron and greater. It's an optical sensor, and so we're picking up number of particle per liter. That's the correct date range, by the way, 12/14 to 1/4. The mean of this data is that 2,500 particles per liter. This is our indoor particle data for non-patient areas, and what we're seeing here is the outdoor data was 2,400, 2,500 particles per cubic liter. What we're seeing here is oftentimes the mean of our data is 0. So we'll have the entire first quadrant and a lot of the second quadrant or all of the second quadrant at 0. And then we'll start to see some observations in the third quadrant and the fourth quadrant. The mean of all of this data is 100, particles per liter, which is just well below the outside air. So, which is to say that we're kind of removing particles very effectively from the air and very continuously from the air. The shape of this chart is odd, with the quadriles being landed a lot at 0. So I'll show a detail. This is what that data actually looks like in the radiology office. You see just a whole bunch of the data clustered at 0. And then what happens is there's particle events in the rooms. And so the particle data in the room spikes. And then the air system, the filtered air and mixing winds up, and the particle just deposition, those particles falling out of the air. You wind up coming back down to your 0 point after the particle events. But the sort of overall picture here is that our particles are pretty well under control and way below the levels that we're even seeing outside. This is the particle data for the patient rooms. Similar data. The mean is a little bit higher, but still in order of magnitude less than particle data outside. And then this is, again, that theoretical relationship. We don't know the exact shape of that curve, or sort of how steep it is and how quickly it bends, but we do know that it is always going to be a logarithmic curve with that diminishing marginal return relationship. In this case, we don't really have a threshold to compare to, and we had a lot of conversations about that within the team. But just comparing the indoor particle data to our outdoor particle data, we're definitely removing particles. We're removing a lot of particles very effectively and consistently. And again, we have every reason to believe that by reducing ventilation rates, we will still be removing particles very effectively and very efficiently. So ostensibly, we can reduce these rooms that are at 10 air changes down to 5 or down to 4 or 2, and we still expect to see this particle data looking very good and like healthy indoor air data. That's the end of the slide deck. We're at 7 minutes overall, which was probably a little bit longer. But if by the way, I'll keep this video up, and any comments that you want to type in here, just in YouTube. I don't think anybody's ever going to find this video searching for it. So if you don't have the link, then you're probably never going to see it. But if you want to type in any comments down at the bottom, then we'll know those as a team and keep those in mind as we move forward with everything. Have a good day. I don't know when you're watching this, but talk to you later. Bye.